Okay, in this video we're going to show you how to calibrate some material. And we're going to start off by doing, from the startup menu, we're going to hit a new file. It's going to make a new numeric project. Let's call this test band. Oops. Alright, so it's set there. Make sure you hit a green check mark to make it. I already have one there. We're going to copy over it. Okay, we're going to come up with this main window here. Some things I want to point out about this. When you have a new machine, there comes no material database for many reasons. Really, a material database should be done with the tools you're using. It has a major effect on the accuracy. So it's very important. That's one of the reasons they don't supply a material database. So at the time of install, you should actually do a test bend of what we're going to be showing you here for most, every material you plan on bending. So let's get started. And first I'm going to show you what it looks like when you do have a calibrated material. So I'm going to start by clicking here, typing in a material that I know has been calibrated. I'm going to hit OK, 0.045 for some 18 gauge. And when I do that, you'll notice that what popped up over here, this indicates that there's material in the database that has been done prior. And you'll see it makes mention of the tools that it used, the BIU021, OZU810. It's indicating it's steel, it's 0.045 thickness, and the tensile strength. So if that's the case, I would have just have to select this, and you'll notice here I got a lot of empty fields, no tools selected and so on, but as soon as I click this, boom, all those are filled up. And as you see, I get all green check marks in my area where that need to be completed. So big time saver if you have this all calibrated. But we're here to show you how to calibrate a material so that you can just check on this very quickly. Alright, now we're going to actually do our calibration. We're going to go again. We're going to start a new numerical project. Okay, we're going to give it another name. Okay, we'll say test 2 for this case. And accept that. Let's go there. Alright, so we're going to start from scratch here. So we'll punch in a new material. Let's say, for instance, 058. So I'm going to punch in 0.058. We're going to hit OK. And so you can see I put that number in. Nothing came up over here. So it definitely needs to be, we have to create a test bend to have the machine figure out how much it needs to go for penetration depth. So right now we'll just answer all these questions manually. So we're going to tell it it's steel. Okay. That's going to input my tensile strength, so that's good to go. We'll give it a width. So depending on what your width of your test bend is going to be, input that. Okay, we're set there. We're going to go ahead and select our tools real fast. And obviously select the tools that you intend on using to bend this material. That's very important. The bigger the V-die, there's a bit of difference when it comes to penetration depth, so very important. Okay, so right now we've got all our basic information set up, but we do need to do a test bend. And since we don't have any material here, we're going to work with these guys. The only real difference between these three is if there's a grain direction. So side to side grain direction, front to back grain direction, or none, which is mostly this one most of the time. So let's click on that real quick. And then this brings up our test bend window. So what we're going to do is we're going to use this to do our test bend. What we'll do is you'll always leave it in auto. And then if you do it manually, or if you turn off auto, you will have to set your pinch point. Okay, we'll do that in a separate video. But for the most part, you'll always do it in auto mode, so the pinch point is calculated automatically. So here's our penetration depth. It always comes up with some sort of number, and over here we get to select which grain direction. We're going to use this for the standard steel. This will come into play later. This we do want to put in our material thick or bend length. it doesn't carry over from our earlier entry. That's okay, just punch it in there and do that. So what we want to do is try to figure out what this penetration depth needs to be. So we're going to click on it. Okay, this window, this input window opens up, and if I happen to know my penetration depth, which is going to be the distance from the pinch point down to the final position where you'll achieve your angle. Okay, so it's a simple number to go off of. What you'll do, okay, if you don't know what it is, we're going to use this little guy over here to do a test bend with. So we're going to click on this, okay, and then you'll see this flashing. What that means is that at this point you can actually use the little jog wheel underneath the emergency stop, and what you'll do once you press on the pedal for bending, the ram will come down at slow speed to the pinch point and stop. And from the pinch point down, you would adjust that by using the little adjustable hand wheel below the e-stop. So you'll turn that. If you turn the wrong direction, it just won't go up. It'll stay at the pinch point, but go the other direction, you'll see the ram will start going down. So what you'll do is you'll eyeball that until you bring the ram down until you see approximately by eye a 45 or 90 degree bend. And when you're satisfied with what it looks like, you just release the pedal and the ram will come up. And at that point, it'll display the new penetration depth here. And if that's all set, you hit OK, and you're going to be back at this window. So what you'll do here now, you'll see your new penetration depth. And then what you'll do is you'll come back over here, measure your actual workpiece, and then you'll enter it in this window. So if you eyeballed 90 degrees, but when you measured it, it measured 85, come in here and type in 85. Basically what that's going to do, it's going to tell the system with this test bend and this penetration depth that it created an 85 degree angle. Okay, so that's your initial test bend, and that'll get you situated and get you really close. So we'll hit the green button to accept it, and we're ready for the next step. All right, so now since we've done that initial test bend with and determining the proper penetration depth, you'll notice that there's a green check here, So we're actually ready to move on to the next step. What we're going to do is create an actual bend. We're going to bend another piece, and so we'll keep this program simple. Tools already selected, and we're just going to let the machine think it's got tools all the way across. And we're going to come over here, program our bend. So basically, the only thing I got to come do is come over here. Let's tell it 90 degree bend. Okay, the rest of this is all good. I'm just going to come over here, and let's just tell the X that we've got maybe a 2-inch flange. Okay, so we're set. We're ready to program. We're ready to run. Let's go to step 5. Okay, and here in our run screen, you'll actually bend your part. You see the first step over here. We're going to go and actually bend this part. Okay, and then you're going to come out, take the part, measure it. Okay, and whatever you measure, we're going to enter it with this tool here. We're going to enter what we actually bent. Okay, it may be close, it may not. Whatever the case is, when I make this correction, okay, I'm going to say I actually bent 91 degrees. Okay, I hit OK. This message comes up. This is important, and depending if which axis you have available, if you're just the operator, you won't be given this option. But what this will allow you to do is add this correction that we just entered into the material database. So what it's going to do is it's going to collect a lot of corrections and improve the performance of the bends as you go along. And what I would do in this case, I would hit yes. I do want that to be saved into the material database. So to really dial in this material, you'll go back and do 2 more bends. You'll make another program, or you can edit this one, add another bend at 120 degrees and another bend at 45 degrees. Do the same thing, do your correction, enter it into the database, and that material will be calibrated. It is important that if you are doing adjustments and adding it to the database, make sure you do it with the correct tooling. If I calibrate a material and I accidentally pick up a different die with a wider bend or wider V die, I'm going to have issues with my bend angle, and if I try to correct it, it's going to apply it to the wrong tool. So it'll mess up the database. So be very careful when you do this. That should be it, and you'll probably want to do this with all your other materials, and then you'll be set. That's it. Thank you.